There are hundreds of billions of galaxies in the observable universe. They come in a few major types, and in 5 minutes, we're going through all of them. Spiral galaxies. Spiral galaxies are the classic postcard shape, a bright central bulge with a flat rotating disk and spiral arms. Those arms aren't solid objects made of the same stars forever. They're wave-like patterns that compress gas and trigger star formation. That's why spiral arms often look bluer. Hot, young stars burn bright but die fast. Typical sizes, about 30,000 to 200,000 light-years across. Star counts range from tens of billions to a few hundred billion. Our Milky Way is roughly approximately 100,000 light-years in diameter and contains on the order of approximately 100 to 400 billion stars. Spirals are gas-rich. A normal spiral might form a few solar masses of stars per year, while some spirals can go through brief starburst phases and form tens of solar masses per year. And if you want to see a spiral up close, not from the inside, the Andromeda galaxy is the nearest big one, just 2.5 million light-years away. Barred spiral galaxies. A barred spiral is still a spiral, but with a straight bar of stars running through the center and spiral arms starting from the ends of the bar. Bars matter because they funnel gas inward. That can feed new star formation near the core and sometimes help fuel an active supermassive black hole. Barred spirals are extremely common. The Milky Way itself is a barred spiral. Visually, think spiral with a handle, but in reality, it's a dynamic structure tied to the galaxy's rotation and gravity. Lenticular Galaxies. Lenticular galaxies are the in-between category. They look like a spiral galaxy with the spiral arms erased. You still see a disk and a bulge, but there's little cold gas and dust, so star formation is low. Many lenticulars probably started life as spirals, and then lost their gas through interactions, ram pressure stripping and galaxy clusters, repeated close passes, or mergers that heated and dispersed gas. Sizes are often similar to spirals, but the color tends to be more yellowish because the light is dominated by older stars. Think of them as spirals that ran out of fuel. Elliptical galaxies. Ellipticals look like smooth, rounded blobs, from nearly spherical to stretched-out football shapes. They don't have obvious disks or arms, and their stars move in many directions rather than in one orderly rotation. Most ellipticals are red and dead. They have little cold gas, so they form very few new stars. Ellipticals range from small to enormous. Giant ellipticals can reach 200,000 to 300,000 plus light-years across and contain trillions of stars. They often sit near the centers of galaxy clusters, built up by mergers over billions of years. Their central supermassive black holes can be monsters, sometimes billions of times the sun's mass. In a way, giant ellipticals are the graveyards of the galaxy world, the end result of billions of years of collisions and merging. Irregular galaxies. Irregulars are galaxies that don't fit the neat Hubble shapes. They can look lopsided, clumpy, or chaotic. Many irregulars are small and gas-rich, with patchy star formation that makes them look messy. Others are irregular because they've been disturbed. Tidal pulls from a neighbor, a recent collision, or ongoing merging. Typical sizes, a few thousand to tens of thousands of light-years. Star formation can be surprisingly active for their size because they often still have lots of gas. The Large Magellanic Cloud, one of the Milky Way's satellite galaxies, is a classic example. Dwarf galaxies. If there's a default galaxy in the universe, it's a dwarf. Dwarfs are small, faint, and easy to miss, but they're everywhere. Typical sizes are approximately 1,000 to 10,000 light-years across, with star counts from a few million up to a few billion. There are several flavors: dwarf irregulars, gas-rich, still-forming stars, messy-looking. Dwarf spheroidals, low gas, very faint, dominated by old stars, often found orbiting big galaxies like satellites. Ultra-diffuse galaxies, large in size but extremely spread out, like ghost galaxies. Dwarfs matter because big galaxies grow by eating them. The Milky Way has absorbed many dwarfs in the past and will likely absorb more in the future. Right now, it's actively pulling apart the Sagittarius dwarf galaxy, a slow cosmic meal happening in our own backyard. Active galaxies. Some galaxies shine insanely bright in their cores because their central supermassive black hole is actively feeding. When gas spirals in, it heats up and glows, producing an active galactic nucleus. Depending on what you see, you might call it a Seyfert galaxy, a radio galaxy, a blazar, or a quasar. Quasars can outshine their entire host galaxy and were more common in the early universe, back when there was more gas floating around to feed those hungry black holes. Any galaxy shape can be active. It's less about the galaxy's outline and more about whether the black hole is currently getting a meal. So that's every major galaxy type. But here's the thing, these types aren't fixed. Galaxies collide, merge, and evolve. The Milky Way and Andromeda, they're on a collision course. In 4.5 billion years, they'll become one giant elliptical. If you enjoyed this quick cosmic tour, subscribe for more fast space explainers, and comment your favorite: spirals, ellipticals, or the weird irregulars.